So here's the
ठीक है.
presentation.
हाँ. कि suppose हाँ I am talking about I'll talk about this मतलब exactly 15 minutes का.
So let's understand
फिर
today
उसके बाद
what
start
is the
करेंगे.
difference between, let's clearly understand the difference between machine learning and deep learning. Between machine learning and deep learning. First, understand that machine learning has, if you classify machine learning, you are always you find yourself only doing two things. One is regression, and other one is classification. Now, this entire machine learning itself can be done in three ways, because your learning is there, right? This learning can happen in three ways. One is supervised learning, one is unsupervised learning, another one is reinforcement learning. So you can have a regression, you can have a supervised regression, or you can have a supervised classification. You can have a unsupervised classification, but there is nothing called unsupervised regression, because unsupervised learning by nature is classification, because you know it involves clustering. Reinforcement is a very different paradigm where continuous weightage calculations happen because of certain policies that you set in. So that's a different ball game. We'll not enter that. Basically, let's understand machine learning has two problems. Either you're regressing or you're classifying. So what is the meaning of regressor? Regressor line that you create. So you have always you will have x and y. X is the independent data set, independent vector. Y is the dependent vector. Okay. So you are always trying to establish a relationship between dependent vector and independent vector. Suppose in our case we have age and salary. Suppose you have many age values, many salary values. Now you ask a question. Do you want to predict salary based on age, or do you want to predict age based on salary? So more likely what we want to do is we want to predict salary based on age. So what you want to predict becomes the dependent. And you say, I want to build a model in such a way that the salary depends on age. So age becomes independent. It doesn't depend on anything, right? So because salary depends on age. So age goes here, salary comes here. Now suppose you have this all this data. So all this data are here, and whatever is coinciding between them is here, right? This is your data, fake data I've created. Now I want a function which will approximate this relationship. Turns out, looking at this relationship is sort of linear in nature, because this is increasing, that is also increasing, right? So linear nature. Now I want a function which will approximate this linear relationship, and most likely because it's a function of which is looking a straight line, we go for the rudimentary straight line equation, which is y is equal to mx plus c. Suppose the same function, same data, suppose it was like this. So overall it is still sort of linear only. So I can decide that I'll just approximate it using y is equal to mx plus c, or I can go ahead and approximate something like this, a little curve. So now this curve came in, so I can see now there is one straight line, there is a second straight line here, then there is a third straight line here. So we want three straight lines to get this curve. Now what happens? You are looking at a polynomial equation. The equation of that looks like this: m1 m3 x3 the whole square plus q plus m2 x2 the whole square plus mx plus c. This is a polynomial equation, but still it's a linear regression only. Okay, you are just trying to capture the variance. If the data is of too much variance, so it's trying to capture it, that is fine. But still the trend is linear only. Small deviations are there, that is fine. When you're doing this, remember that in a linear regression, both are continuously varying. Both independent and dependent are continuously varying. That's why you fit a linear regression model. Okay, now what if you have salaries and your grades, what grade they are working in? So let's say you have only three grades. Now this is continuously moving, but here there are just classes: class A, class B, class C. So the continuously moving data, and you're saying for all of this it is class A. Okay, nice, like this. Okay, for all of this it is class A. Then for all of this, it is class B. So let's say class A, class B, class A. So salaries from this range to this range, they are class A officer. Salaries from this range, there's class B officer. Salaries from this range to this range, they are class C officers. So you want to fit a curve which is going to classify. You can call this, you usually call this as a logistic regression. Okay. Both ways we have fit a curve. It's called curve fitting. It has many names. Curve fitting is one way. What are you fitting? You're fitting a curve. Fitting a curve where? Fitting a curve between input and output. Okay? Fine.
Mhm.
So now to talk mathematically about what learning is. Talk about mathematically what is learning. Mathematically learning is nothing but creation of a function approximator. So all ML algorithms are nothing but function approximators. It is approximating the function between, it is approximating the function. This function is supposed to be the relationship between feature vector, which is your input, and target vector, which is your output. That's all. Okay, this is a function approximator. But not all relationships are linear or almost close to linear. Not all. Sometimes you are looking at non-linear, not sometimes, mostly all the time we want to approximate a non-linear relationship. This is most important to understand. So when you're trying to approximate non-linear relationship, your local machine learning functions algorithms will fail because non-linearity. For example, if you want to understand what non-linearity is, let's say you have group A, group B, group C, and let's say all of them get fever. For group A, you will give Dolo 250. For group B, you will give Dolo 450. For group C, you will give Dolo 650. Group A, after taking fever, did not go. Group B, after taking 450, fever went away. Group C, after taking Dolo 650, you are expecting the fever to go, but it did not go for some reason. Okay, now this if you want to plot how it looks, 0 1, fever not gone, fever gone. But now there are values. For Dolo 250 you have one value, for Dolo 450, Dolo 650. Okay, this looks something like this. This is non-linearity. To get, see, now we have to now fit this curve. This curve is not so easy to fit because you have to stitch this curve, can't fit this curve. That's the difference. Earlier we were fitting the curve between the data. Now we will have to stitch the curve to model this non-linearity. Okay, so I want to model this non-linearity by taking small, small curves. These small, small curves comes from what we call as activation function. I'm going to take this activation function and I'm going to build a lot of neural networks, and this activation function is in each of the neural networks. Each of these neural networks is connected to each other, and together we will build the entire nonlinear function. So let's go into a visual platform where I will be able to explain what this activation function and nonlinearity is doing in a much simpler way or visual way. Suppose we have this data set with us in front of us. So I'm calling this data set. Okay, you have to. It's a visual, but let me make it easy for you to understand what this actually is. This is the given data. We want the machine to understand and learn about this given data. What exactly what we want? Suppose I'll put a dot here. Okay, you tell me which colors this should be. I have put black, but what color should this black dot be actually?
You are asking a question.
Yeah.
This is -3
No,
and
what color should this be?
blue, blue,
Blue. And if I put one dot here, what color should this be?
orange.
Now you said this because you are looking at it visually, correct?
Yeah.
But can the machine understand this? That's what we want to do now. So if I want to see this entire data as a set of data, like how you actually feed the data to the system, you see this point here. This is 0.1 and this is -4.1. So 0.1 minus 4.1 is a coordinate whose color code will be blue. So anything else now? Anything another? Let's take this. Okay, this is 5 and this is 0.2. So 5 and 0.2 is orange. Like that, you can for every dot that you're seeing here, you can generate this as a blue, orange, 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 blue, orange. We'll have this. This is the whole data set. This we will For this we will attach two output layers, and we'll say now go ahead, I will give you enough neurons to go ahead and build the non-linear. This is so non-linear, you see. Earlier we are talking about this, but see the non-linearity here. This is such a very complex non-linearity that you're looking at, right? So you want the machine learning model or this deep learning model to use up all these neurons to stitch. I told you to stitch that curve. Now, stitching curve, I told you there's something called an activation function, and an activation function is a function that activates or has the capability to activate every neuron. So every neuron will have an activation function inside it. And once you decide you want an activation function, every neuron will have the same activation function. It's not like you will use activation here different, or maybe there are models that can use different activations. That is also there, multi-stack models. But here in this case, once an activation function is set, all of them will have the same activation function. For example, you have sigmoid function. Sigmoid function looks something like this. So for all negative values, till it comes to 0, it will be 0 only. After a while, when it is after a while, you're supposed to hold there, and as soon as you get the first positive value, you gradually change and come, right. So you activate the neuron like in this fashion, slowly. Then there is another activation function which is ReLU, which looks like this. Okay, it's like 0 0 1 if it is 1. Okay, so it's just like, or x, it's not 1 if it is 1. 0 is, it's like f of 0 comma x is equal to x. 0 comma goes like this. Okay, whatever is the value here, it will go. What otherwise, if it is negative also, it will be 0 only. Okay, so that is what this means. So it is going to just it's going to activate this neuron in this fashion. So we are going to take these stitches, these curves, and we are going to use parts of these curves to stitch back this non-linearity model, a non-linear model person. Right now, how do we achieve this? We achieve this by starting with certain hypotheses. The first hypothesis, see, this is the real output. But here we are starting with a gamble. We are guess. We are starting with a guess. We are starting with a guess saying, actually, what we want to know where the blue should come, where the orange should come, where the blue should come, right? Here we start with the guess saying everything on the left side vertically divided is orange, everything on the right side vertically divided is blue. Same way, horizontally up, horizontally down, blue and orange. Same way, middle is all orange, left, the others are blue. Here, middle level, vertically, horizontally is orange, everything is here. This quadrant is orange, the other quadrant is blue. Different variation of the guess itself. So that's why it's all different variations. Once these variations are given, then we bring a neuron, and we say, now you see, we all these neurons are connected to each other. So we'll say, you boss, you look at all these guesses and come up with your own guess. Then this neuron will also be asked to do the same. So of course it is random, it is probabilistic in nature. Everyone will come up with probably its own guess. So what you have a network of a hidden layer of gamblers who are guessing. So it will start with first hypothesis. Your hypothesis is taken in forward propagation. Then it sees the hypothesis meets the reality. Okay. Now the reality is equipped to tell the hypothesis maker that you are very close, or you're not at all close at all, or you're coming close, or you're beginning to come here. It'll express it in terms of weights. That weight is propagated backwards to the starting point, and they now tweak that guess. They'll say, acha, you think I'm almost going, so let me think in that direction and move forward. So this forward propagation, backward propagation keeps happening until it comes to the proper. This is exactly how image processing is also learned, how voice processing, how text processing, everything. This is how it learns. And of course, our work is to convert our data into a field of numbers. So today, this is how machine learning and deep learning is different. Deep learning is a universal function approximator because you have infinite number of neurons that you can use. Of course, you should not use infinite neurons because otherwise it will overfit. Same way, even with your polynomial regression that we were using. Suppose you are doing something like this, correct? So if you try to overfit and use a high degree of polynomial, you're going to end up overfitting. So always there is this field where you do bias, variance,
Variant.
trade-off, okay, so that you limit the number of neurons and sort of give us some degree of freedom to the model so that it can work better on the real population data, right? So that's all. So that's the end of it.
बेस्ट ना वो रिकॉर्ड खत्म कर दो. ये हुआ 20 minutes.
In between you will be asked doubts, no? So that is also there.
ठीक है. तो अब ये तुम मेरे को लिंक दोनों वीडियो ये भेज देना. मैं आई विल ट्राई विद द पेन कि मैं कर पाती हूँ या नहीं पाती, वो ट्राई करूंगी बीच में. अच्छा, अब मेरे को बताओ क्वेश्चन